on this computer. There we go. All right, and let me share the appropriate screen. All right, so let's take a look at number 8 first. So this is page, we're reviewing the homework. This is page, and where's my my toolbar here for my Microsoft whiteboard? I don't see it. I don't see it down here. All right, this is not cool. Let me stop the share 1 second. Let me go ahead and open, close my whiteboard, reopen it. It should have the tools at the bottom. There it is. Now it's working fine. And going to my Zoom meeting, and now am I still recording? Yes, I'm still recording. So I'm gonna go ahead and share Microsoft Whiteboard, and there we go. All right, wonderful people. So number 8 says, this is on page 125. It says, a squirrel is collecting nuts. It collects 5 nuts on the first day of the month. So I'm going to write 5, 8 nuts on the second day. Bless you. 11 nuts on the third day, and so on in an arithmetic progression. So this is an arithmetic progression. So, bless you. So now it says, how many nuts will it collect on the 20th day? So we want to know on the 20th day, how many nuts? Now, this is the first day, this is the second day, and this is the third day, and it goes on. At some point, it's going to be the 20th day. And I should write it differently. It would be a 20th. So how would we figure that out? Well, I think I gave you 2 formulas. One formula said, why is this doing that? There we go. Ideal. Let me make this. So A's of n equals to A's of 1 plus n minus 1 times D. So this one allows you to figure out an individual element in the sequence, in the arithmetic sequence. So in this case, the first element, the first term would be 5. The common difference here is clearly 3. So if you want the 20th one, it'd just be 5 plus, well, 20 minus 1 is 19. So I'll just write 19. Yeah, times 3. And so you have 5 plus 19 times 3. What's 19 times 3? Well, 9 times 3 is 7, carry the 2. 3 times 1 is 3 plus 2, 57 plus 5. So how many nuts will he have? 62. Agreed? Okay. So part B, let's see if part B is more interesting. After how many days will I have collected more than 1,000 nuts? So how many days would it have collected more than 1,000 nuts? So in other words, we want to figure out what n, A's of n, is greater than 1,000. Oh, well, let's be careful. Let's be careful here. When S of n is greater than 1,000. So on any individual day, he collects some nuts. And obviously, but on the first day, he would have collected 5 nuts. But on the second day, he would have collected 8 more. So that'll be 13. And then on the third day, it'd be 11 more. So now we're up to 24 nuts, right? And so on and so forth. So we're going to be doing a series now. So you have S of n equals to half n times twice the first term plus n minus 1 times d, if I'm not mistaken. And so what you do is you're going to go ahead and try to figure out what n happens. I'm going to set it equal to 1,000. So in other words, I'm going to set S of n equal to 1,000 equals to half n times twice the first term plus an unknown n times 3. So what we have is we have 1,000 equals to half n times 10 plus 3n minus 3. I use distributive property there. And so you have 2,000 equals to n times 3n plus 7, if I'm not mistaken. So you have now 3n squared plus 7n equals 2,000. We may write this as 3n squared plus 7w minus 2,000, for this is a quadratic, and we're going to write it in standard form. Now let me grab my calculator. And our job now is to solve that quadratic. So I'm not sure we can factor this. It doesn't feel like it. Those of you who tried it at home, was it factorable or was it not? It doesn't feel like it is, right? I might be wrong though. Doesn't feel like it. So A is 3, B is 7, C is negative 2,000. I'm going to go ahead and use the quadratic for me. So X equals negative B. Yes.
Hello.
Yes.
Liane and Tiara are going home.
Okay.
Thank you.
Have a great day. So we have negative b plus or minus the square root of b squared minus 4ac all over 2a. And just gonna go ahead and substitute this. Negative 7 plus or minus the square root of 7 squared minus 4 times 3. Take care. Times negative 2,000 like this. All divided by 2 times 1. I'm gonna go ahead and do the calculation. Obviously, we're gonna get two different values. So we got 49 minus 4 times 3 times negative 2,000 in parentheses. And then we're going to square root that. So this is basically negative 7 plus or minus the square root of 24,049, all divided by 2. And so plus negative 7 divided by 2. So we get one answer is 74.03. The other answer is negative 7 plus this divided by 2. Wait, it should have been minus, of course. Now, this other answer is also a solution to the quadratic. However, because it's negative, it won't make sense. So negative 81.0. And so we're going to say after the 74th day, so by the 75th day, by the 75th day, the squirrel would have collected 1,000 nuts. Because at 74, it wasn't quite that much. Now, let me make sure I got this answer correct because I felt like I was rushing the quadratic. Want to make sure you guys have decent notes. And it's completely wrong. Is this section 8C? Yep. Is this 8B? The answer is supposed to be 25. So that's really wrong. So let's see where the mistake has been made. All right, so let's go right here. All right, everything's set up correctly here. 2 times 5 plus n minus 1 times 3. Everything is correct there. Everything is correct here. I don't see an error yet. Oh, I see my error. It's a very simple, dumb error. It's right here. You're supposed to divide by 6. 3 times A. 2 times A, sorry. So I'll correct these right now. So even though on an numerator, I correctly identify A, and the denominator just defaulted to writing A equals to 1. And that's sad, but it is what it is, guys. No biggie. So it comes out to 24.67. Sorry about that. 24.67. And the other one comes out to be negative 27.01. Well, it's positive for one thing. It's positive, and it makes sense. And well, it's yeah, that's it. That's pretty much it. It's the only one that makes sense. So there we have it. Now let's take a look at number 9, the next question. But did you see how I was able to find my mistake rather quickly? A lot of you, when you're doing your work on your test, and I'm checking it, it's making me not want to check it because your work is not very good. I'm not saying my work is that much better than yours. However, I feel like you can follow my work step after step after step. And so you got to make sure that you guys are trying to get in the habit of being very explicit on your work so you can find mistakes, and so that people who check your work can actually check it and feel like checking it because it makes sense. So let's take a look at number 9. It says, Carlson is given an interest-free loan to buy a car. She repays the loan in unequal monthly installments. These start at 30 in the first month and increase by $2 each month after that. She makes 24 payments. So number 1, n equals 24 is the amount of payments she's gonna make. Her first payment, the first term, is 30. And the common difference here is 2 because she adds $2. So therefore you can imagine that this starts at 30, 32, then goes to 34 each month after that, all the way to the 24th term, whatever that might be. Now, the first part of the question asks, find the amount of her final payment. So her final payment will be what? Well, this happens at a to the 24th. So if we look at our formula, a's of n equals for determining a particular term of a sequence of a known arithmetic progression or sequence, we have the following formula. So a to the 24th must equal to 30 plus 24 minus 1 times 2. So a to the 24th equals 30 plus 23 times 2. So it should be 30 plus, well, that's 46. So we're going to end up with 76. So her final payment is 76. Now, part B says find the amount of her loan. Well, since this is a zero interest loan, we can assume that, assuming she's not overpaying by the end of the time, that the sum of this sequence or the series will be the loan amount. So we're just going to solve for S of 24. Now, it's instructive for me to write the formula down first. So S of n equals half n times twice a's of 1 plus n minus 1 times d. So S to the 24, S of 24 is half times 24 times twice the first term, which is 30, plus 24 minus 1 times the common difference, which is 2, I believe. And that's it. I mean, the rest is just simplifying. And that's it. And so that was her loan amount, which you can't see. I'll scroll it up. And again, it's just the great thing about these questions is they're really straightforward. Some of them are not as straightforward. And those I want to make sure I cover with you guys. But again, in order for you to do well on this, you need to do the homework, you need to do the problems, you need to struggle. Without the struggle, you're not going to get better at any of these things. Now, I know some of you already kind of know this stuff, and that's good for you. But then when we get to stats, get on point. Plus, it's good to, do your duty. What's your duty? Do your work, do your homework, keep your house organized, keep your room organized, drive safely, maintain your car properly, speak appropriately, the best you can, whatever. I don't know. Maybe I'm wrong. Okay, so now we're gonna do number 10. Does it look pretty straightforward, guys? I think so. So let's try 10A. 10A says find the sum of the natural numbers from 1 to 100 inclusive. So from 1 to 100, find the sum. Well, we said that the triangle, this is the triangle number sequence. We gave a formula for it. So the triangle number sequence, well, basically the sum of it was half n times n plus 1. Is that correct? That's what the formula for it? That's the formula we gave for the triangle number sequence. Do you remember that? Now, what I want to make sure you realize that this is a special case where a's of 1 equals to 1, the difference equals to 1. So if you just went to this formula here, you were at S of n equals to half n times twice a's of 1 plus n minus 1 times z. And you said, well, what's a's of 1 here? A's of 1 here is 1. D is 1. So you write S of n equals half n times twice times 1 plus n minus 1 times 1. And so you have S of n equals half n times 2 plus n minus 1. And S of n equals half n times n plus 1. This, you see that this formula here is just a special case where a's of 1 equals to 1 and the common difference is 1. It's just an arithmetic progression. So the series comes up the same. You get the same formula. So the formula we came up with for the triangle number sequence series is just a special case of an arithmetic progression where a's of 1 equals to 1 and the common difference is 1. Fair enough? So then all you're going to do here is you're going to go, well, S of 100 must equal half times 100 times 101. And so 100 times 101 is 10,100 divided by 2. And so the sum has to be 5,050. Now notice that each of these problems puts to test not only the formulas and the concept we just learned, but it continues reinforcing your algebra skills. In each of the problems we've done today, we've done quadratics, we solved linearly stuff. Just notice how much of the algebra you actually use. Now part B for 10, it says find the sum of the natural numbers from 101 to 200. Inclusive, meaning also include 101 and 200. Let me write inclusive better. Now, obviously, we're going to add 101, 102, 103, 104. Now, there's a few ways of doing this. The first term here will be what? A's of 1 will be what? 101. Now, the common difference here would be what? It'd be still 1, right? And, well, that term there, well, from 101 all the way to 200, how many numbers are there? From 1 to 10, how many numbers are there? 10. From 1 to 100, how many numbers are there? 100. So from 101 to 200, how many terms are there? What? Do you say 99? No, I think it's 100. Here's why. Well, it said to the problem, said to 200. I don't know. Look, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10. So from 1 to 10, we have 10. So from 1 to 100, we have 100. So from 101 to 200, we have how many terms? 100. I mean, I don't want to count them. Is it 99? Oh, because you're subtracting, you're not counting. Okay, how many numbers do we have from 1 to 10? What's 10 minus 1?
Well,
Well,
by counting, are you counting 1? That's the thing, is if it's going 0 to 10 is 10, but if you go 1 to
all right, don't overthink this because that's what happens. How many terms do we have from, if I go 1, if I write down 1, 2 to 10, we have 10, but 10 minus 1 is 9. So never do counting like subtraction. Subtraction is different from counting. The way you count is you subtract and then add 1. So from 1 to 5, how many numbers do we have? 5, but 5 minus 1 is 4. So we say this, 5 minus 1 plus 1. All right, counting is different than subtracting. This is an important concept. So how many numbers are from 2 to 9? 9 minus 2 is 7. plus 1, 8. There are 8 numbers, 2, 3, 4, 5, 6, 7, 8, okay? But you got to remember how to say the word inclusive because I have to include the endpoints. Does that make sense? All right, there, good, good. All right, so we have, so how many terms do we have? We have 100, right? Now, in theory, I should just go sum of n equals half n times twice the first term plus n minus 1 times the common difference. And so S of 100 must equal half times 100 plus twice times 101 plus 99 times 1. And that should give you the answer. So let's do it. So 101 times 2 plus 99 times 100 divide that by 2 is 15,050. I mean, it feels a little high to me, but that's fine. I think it's good. Now, there's another way you can check this real quickly, which I'll perform. Just because, you know, you can find out some of you might say, oh, well, I can find out from 1 to 100, it'd be 100 times 101 divided by 2. And then from 1 to 200, it'd be 200 times 201 divided by 2, right? And then you would subtract them. Does that make sense? So 200 times 201 divided by 2 comes out to 20,100. And then you subtract what it would be for 1 to 100, which is just, it's just going to be 5,050. So this comes out to 5,050. This comes out to 20,100. And when you subtract 20,000 minus 5,050, you get 15,050, which is the same answer we got up top. All right, part C says, find and simplify an expression for the sum of the natural numbers from n plus 1 to 2n inclusive. Well, that's a more interesting type of question. So let's do that. Find and simplify for natural. So let's see. Here we have n plus 1 all the way to 2n. And so what, and it says for the sum of the natural numbers. All right, so what is the first term going to be here? What's the first term? N plus 1. What's my common difference? It just be 1. Okay. Now, my final term will be 2n. So maybe I want to, and they want me to find something for the sum. So let me see. I don't know if I can find 2n there. Let me just go ahead and play around with this. So S of n equals half times n plus twice a's of 1 plus n minus 1 times d. All right, that's our formula. I don't like the notation right now. I don't like the notation. So I'm going to switch. Because that n there is going to mix up with the other n for the amount of terms in the sequence. So I'm going to change this to x, and this will 2x All right, it's the same meaning. I'm doing that because I don't want it to mess with my, maybe it's supposed to be that. I don't know. So S of n equals half times n times twice the first term plus n minus 1 times 1. So S of n must equal half n times 2x plus 2 plus n minus 1. S of n equals half n times 2x plus n plus 1. It would be nice to know what n is. If we start at x plus 1, when would it be twice x? Well, we don't know. We don't know. I'm not satisfied with this formula. I look at it, doesn't make me feel good. Let me take a look at what they want to produce, but perhaps the n, keeping the n the same will make it worthwhile. And for the sake of time, let me go ahead and move. All right, so they essentially allowed x to be n, which I'll go ahead and do it. So I'm going to allow for x to be n. And I didn't like doing that because I like to keep them separate, but whatever. This is their book. So I'll go ahead and replace the x with the n. And I get the same answer as the book did, which is allowable. However, it would be nice to know what n is. So this is what they want. That's what they want. Yes. Only if you are. Be careful, yes. You're welcome, Mama. All right, guys. So let's take a look at 11. I was reading an email there. An employee starts work on January 1, 2020 on an annual salary of $30,000. So January 1, 2000 is $30,000 salary. His pay scale will give him an increase of $800 per annum. So, oh, sorry about that. So January 1, 2001, it should be 30,800. Until January 1, 2015. So January 1, 2015. So that would be 16. So from 2000 to 15, there are 16 years. 16 years. It must be miserable. He remains on this salary until he retires. So he remains on this salary until he retires on 31 December. How much will he earn during his lifetime? So his pay scale will give him an increase of $800 per annum on the 1st of January until January 2015. He remains on that salary. So whatever money he had here, whatever he was making on that day, he will continue to make until January 1, 2040. Actually, it says to the end of that year. To the end of that year. So December 31st, 2040. So how much money will he earn during his working life? Now, from 2016 to 2040, that's 40 minus 16 plus 1. There are 25 years. So this is 25 years. So what we're going to do is we're going to go ahead and if you could see this here, we're going to figure out the sum here. We're going to figure out how much he made here, how much. And then we're just going to take 25 times this and add it together. So it's two problems. So we're going to have basically A's of 1 is 30,000 here, right? The difference here is 800, and the n here is 16, right? Now to find this guy here, it just would be A's of 16 equals to 30,000 plus 16 minus 1 times 800. So that's going to be 16 times 800. No, 16 minus 1. Let me make that prettier because I could hardly tell. It's actually 15 times 800. 15 times 800 plus 30,000. That's 42,000 right there. You can already figure out that this here is going to be 42,000 times 25. So for the remaining 25 years, he would have earned a total of 1,050,000. And then for the first 16 years, so here's one set. The first 16 years, and I'll scroll to the side so everybody can see. For the first 16 years, he would have basically S of 16 of half times 16 times twice times 30,000. Twice A. I already forgot the formula. Can you believe that? There you go. Plus 15 and minus 1 times the common difference 800. So if I do all this, that's 60,000 plus, oops, I put 3 plus 15 times 800. I gotta get my wife a Christmas present, man. Times 16 divided by 2. If I don't get her anything, she's gonna be upset. Like really upset. Wait, I did something wrong. 30,000 times 2 plus 15 times 800 times 16 divided by 2. That feels awfully wrong. That feels, oh, because I keep on putting 3,000. 30,000, there we go, times 2 plus 800 times 15 times 16 divided by 2. I'm getting, for the first 16 years, would have earned $576,000. So we take 1,050,000 and add $576,000. So 1,050,000 plus 576,000, and we get $1,626,000. And I think that's correct. Yeah, that's correct. So those were the more difficult questions from this section, in my opinion. So they're not difficult at all. Now, to wrap it up, let's take a look at number 3. 3C was a question that Galia asked for. And for 3C, first of all, we got to remember it says in the following arithmetic progression, the first 3 terms and the last 3 terms are given. Find the number of terms. Well, 8, comma, -2, comma, -4, and then -202. In the following, the first 3 terms and the last term are given. So I think this is pretty straightforward. A's of 1 here is 8, and the common difference is, well, it's -2 minus 8. So it looks like the common difference is -10. -2 minus 8, -10. But no, wait a second. Did I write this correctly? Oh, wait, I wrote it wrong. This is a 2. This is a positive 2. -2 minus 8, sorry. 2 minus 8 comes out to -6. Now we're good. So the first thing I would do here, since they want to find the sum, is I gotta figure out n. So the way I'm gonna do this is that last term right here, this guy, I'll write A's of n equals A's of 1 plus n minus 1 times d. This is the formula for a term in a particular arithmetic sequence or progression. So -202 equals to a plus n minus 1 times -6. So that's -202. And nobody says anything. My gosh. I wonder if you guys are just sabotage. Here we go. I'm not gonna lie to you. I'm starving right now. I had like a stomach flu on Saturday. I got it from the girls. And so at least I'm losing weight. By the way, I'm getting very, very close to my final numbers that I want to be at. So I'll make adjustments to it, but you know. So take -216, divide that by -6, and we have n is equal to 36. So we know that the last term happened at 36. And it's 36. So what I'm going to do now is I'm going to go ahead and do S of n equals half n times twice A's of 1 plus n minus 1 times d. But for S is 36. S of 36 equals half times 36 times twice times 8 plus 35 times -6. And that's it. So 35 times -6 plus 16 times 35 times -6 plus 16 times 36 divided by 2. And it says that the sum of 36 of the 36 terms would be -3,492, which makes sense to me because you start getting those negative numbers. It's quite a few of them. And I think I'm good. So that's 3C, that's 36. Yes. Only if you are careful. Oh, well, they didn't ask me to do that, but whatever, I did it. They just asked me for this. All right, wonderful people. I'm gonna go ahead and end this thingy here. I want to go ahead and get the Zoom ready or for the doctor. So let me do that right now.